Call of Duty Ghosts is not a great game, but aside from a fairly divisive multiplayer and a pretty awesome alien invasion mode, the campaign, while somewhat cheesy at times, contains an intriguing depiction of an orbital space weapons system. And ever since the game's release over 10 years ago, this always made me wonder, what's to stop a space-capable military from simply dropping bombs from outer space? And at that rate, why not just drop a huge chunk of metal from outer space and have it impact a target at high velocity? Which, curiously, we don't really see much in science fiction. This game really got me thinking when I found out that this weapon system is actually based on a historical Air Force research project. But while the concept of operations sounds fairly simple at first glance, it still begs the question, is this actually a feasible means of delivering a military strike? And if so, could somebody build one of these? Now, as I mentioned, this game is over 10 years old, but in that time, I've gotten a couple of engineering degrees and started working at a private company building a space station. So I thought this would be a good time to see if the space weapon systems depicted in Call of Duty Ghosts are actually realistic. There have been a few historical research projects to develop something akin to what we see in Ghosts. An early form of this orbital bombardment system was proposed as brilliant pebbles as part of the Strategic Defense Initiative. This system would take the form of a constellation of satellites that would be able to descend from orbit to impact an ICBM en route, essentially acting as a space shotgun to shoot down ballistic missiles. The earliest form of this orbital strike weapon that we see in Ghosts appears to be Project Thor, a conceptual weapon system that would launch telephone pole-sized tungsten rods from orbit. In 2003, a US Air Force report described the system as hypervelocity rod bundles that would accomplish essentially what we see in the game. And of course, in G.I. Joe Retaliation, we see a orbital weapon system similar to what we see in Call of Duty Ghosts, which interestingly came out the same year as that movie. One of the primary sources we'll be using in this research project is a 2002 document from the RAND Corporation titled Space Weapons Earth Wars, which contains extensive analysis of conceptual space weapon systems, as well as discussions of their military applications and implications for global security. If you're interested in researching more about these orbital weapon systems, especially the non-engineering aspects, this would be a great document to start with. It's important to remember for this discussion that an object that is orbiting a planet is not just floating in space over the surface of the planet. Rather, it is falling around the planet in such a way that it just perfectly maintains its altitude above the surface. But maintaining this altitude requires an input of energy, as if the velocity drops too much, it will fall from orbit, or if the velocity is too high, it might escape the gravity of the planet, never to return. This is why satellites and space stations still require propulsion systems in order to maintain their orbital trajectory. Now, with this in mind, there are several ways to accurately drop something from space on an intended target. The easiest way is to simply alter the orbital trajectory such that it will begin falling towards Earth towards the intended target. So for the rods inside the satellite, for example, this would essentially involve launching the rods on a non-powered trajectory around the Earth in a way that they will gradually descend towards the surface. However, if the rods are simply being released from the satellite and left to fall towards Earth, this would take quite a while for them to actually reach the surface, and as a result, it might not be an effective method for a time-sensitive application. This also wouldn't result in the rod being launched straight downwards, as we see in the game, so this doesn't seem to be the approach being used here. A more direct approach could be accomplished by using some sort of propellant to fire the rods towards the surface of the Earth. Essentially, a downwards-facing orbital space gun. This seems more likely to be the method utilized by ODIN, as it allows the projectiles to reach the surface in a shorter amount of time, and with more precise control over their flight path. However, it's also important to keep in mind that the rods would maintain their orbital velocity, which they inherited from the satellite. You could think of it like an aircraft dropping a bomb. Once the bomb drops, it doesn't fall straight down, and instead follows the flight path of the aircraft in addition to dropping downwards. This would have to be taken into account when firing the rods from the satellite, but it doesn't make it impossible to hit an intended target this way. A third way to accomplish a targeted drop would be to use powered re-entry, which appears to be the method utilized by the LOKI satellites. This would involve a rocket engine attached to the rods, which in addition to propelling the rod back towards the surface of Earth, would also allow the projectile to be steered. Combined with an effective targeting system, this powered re-entry would then allow for much more precise targeting than either of the previous two methods. While we're still on the subject of orbital mechanics, there's some interesting attention to detail regarding the orbital placement of Odin during the opening sequence, although there also appears to be some flaws in this presentation as well. According to the opening sequence, the rods fired from Odin take approximately 15 minutes to hit San Diego, California. According to the RAND report mentioned earlier, this travel time would theoretically be possible only for a satellite orbiting above a point on the Earth within about 5,000 kilometers from its target. In the space sequence of the first level, we see Odin orbiting above Baja California. It's difficult to tell for sure, but this appears to indicate that the ground track of the satellite is within the 5,000 kilometers specified by the RAND report. Now, this also brings up the challenge of orbital placement of the satellite, which in the game is specified to be within low Earth orbit. Now, this is approximately the altitude of the International Space Station, so it's not infeasible to place a satellite here. However, for a weapon system in which readiness at any given point in time is essential, it might be more effective to place this satellite in what is called a geosynchronous orbit. In this orbit, the satellite is tracing out approximately a figure 8 over a specific region on the ground below. Thus, it would maintain its readiness in the event of a firing decision. Even more optimal would be a geostationary orbit, in which case the satellite is orbiting over a specific point on Earth at all times, since it is orbiting at the same speed as Earth's rotation. There are two challenges with this, though. For geosynchronous orbits, you need to be at a much higher altitude than low Earth orbit, which would be inconsistent with the stated setting in the game. Also, for geostationary orbits, this is only feasible over the equator of Earth, which, while it appears we are located near that region, you have to be at an even higher altitude for this to work. Also, in geosynchronous and geostationary orbits, because you're at a higher altitude, it would take much longer for the projectiles to reach their targets than if you were located in low Earth orbit, which again reduces their usefulness to some extent. Thus, being in low Earth orbit does make sense from the perspective of reducing time to impact. However, it also means that you're going to be orbiting the planet very quickly, and thus the satellite might not be available to strike a target when it's needed. So I suspect that the placement of the satellite over Baja California here is intended to imply that it could be in some sort of equatorial orbit, but since the game specifies that we're in low Earth orbit instead, this could be considered an inconsistency. But again, this is more of an implication rather than directly stated by the game. The RAND report also makes mention of using propulsion systems to reduce the flight time of projectiles on their way down to Earth. This might explain the use of the LOKI system, which appears to be capable of delivering the rods in a shorter amount of time than ODIN. In one of the intel files, we get some more information on the specifics of the tungsten rods used as projectiles to be fired from ODIN. Tungsten is selected as the material since it possesses the highest melting point of any known elemental metal, providing maximal survivability for atmospheric heating on re-entry. The rods of tungsten are specified to be 6.1 meters in length and 0.3 meters in diameter, which when converted to American is approximately 20 feet long by 1 foot in diameter. This also appears to be the exact dimensions specified in Project Thor. In historical reports, the entry velocity for these rods is specified to be up to Mach 10. However, I couldn't find any primary sources for this, and the sources I did see for this were primarily news articles. But in the interest of being thorough, I went ahead and did some simplified calculations to determine what sort of energy yield we could expect from these tungsten rods. One of these simplifications is that I am neglecting the thermal energy acquired as a result of aerothermal heating. Another big simplification that I'm making is that I'm calculating terminal velocity using the atmospheric density at sea level, since this is the highest density of air that we would be encountering on our way down. So with these simplifications and using the numbers from the Intel files, our resulting explosive yield is on the order of 1/10 the blast power of the World War II Little Boy and Fat Man atomic bombs. However, if we modify the shape of the rods to utilize the more efficient nose cone shape of an ICBM, we can reduce our atmospheric drag coefficient, giving us a faster terminal velocity. And the resulting increase in impact speed would bring us to an explosive yield on par with the World War II atomic bombs. Now for the case of the LOKI tungsten rods, if we allow them half the volume of the ammunition utilized by ODIN, as well as the improved nose cone shape that we see in the game, we then end up with an explosive yield of about a quarter of the World War II atomic bomb blasts. Now again, these are simplified calculations, so you're welcome to check my work and let me know if I made any mistakes or did anything wrong here, but this at least gives us a ballpark figure for the sort of explosive power we could expect from these orbital weapons. The The ODIN satellite consists of 4 magazines to hold the tungsten rods, a launching system to drop the rods downwards, a solar power generation system, and what we could call a service module containing the control and propulsion systems. The overall shape of the satellite is cylindrical to fit inside the payload fairing of whatever sort of rocket system is used to launch it. From our previous discussion, we can assume that there is some sort of propulsion system used to fire the rods downwards, which could be either electromagnetic or chemical. Now, chemical propulsion would essentially be the same mechanism as shooting a gun, where you're producing a force through the explosion of a propellant. For this to work, though, you would have a lot more structural considerations, considering that you have to contain this explosion, in addition to needing to resupply the propellants that you're using to create this explosion. And since there's no air here to work with, we have to provide an oxidizer in addition to a fuel, which increases the complexity of the plumbing you would need. A more effective method then might be electromagnetic propulsion, such as a coil gun or railgun. In this method, all we would need to propel the rods would be electricity, which can be acquired from the solar panels. This would then probably require significant energy storage systems, otherwise the satellite might require a considerable recharging time in order to fire again. Now technically you could also use a mechanical launcher system like we saw in G.I. Joe Retaliation, but personally I'm skeptical that you could get the same firing capabilities from a trebuchet or a crossbow that you could from a cannon or a railgun. So I think we can probably rule out that method, especially considering what we see in the game. As we also get to see up close and personal, there is a propulsion system at the top of the satellite. In-game, it's referred to as a reaction control system, which are essentially small rocket engines used to perform small adjustments to the satellite's position and/or orientation. Also, RCS don't necessarily need to use a bipropellant combination, and sometimes just compressed gas is sufficient, as is the case in astronaut propulsion units. We can see similar engines being utilized on the space shuttle as it performs its docking approach. Thanks to the intel files, we can actually get some sense of scale for the ODIN satellite. The tungsten rods it fires are specified to be 6.1 meters in length, which converting to American is about 20 feet. Considering that the rod magazines make up about a third of the total height of the satellite, we can estimate that the satellite's approximate total height is 60 feet. Thus, it would be approximately the correct size to fit inside the payload bay of the space shuttle, as well as perhaps some fairing sizes in the Atlas and Delta rockets. Now, the overall diameter might be a little much, but that could potentially be solved by attaching the magazines after it's launched. This also would require the solar panels to be folded down while it's being deployed. So then, at least as far as volumetric dimensions go, a satellite of the overall size of ODIN could potentially be launched from existing technology at the time. Later in the game, we encounter the LOKI satellites, which are reverse engineered based off of the ODIN weapons platform. The overall configuration of the satellite is much smaller than ODIN, as well as the projectiles it's designed to fire. From the ground facility we discovered them in, it appears that they are individually being loaded into rockets for launch and deployment into space, with the goal of forming a constellation of at least 23 satellites. The game also specifies that LOKI satellites are also placed into low Earth orbit, and so the increased number of satellites makes up for the reduced amount of time that these satellites would be spending over any particular location. That is to say, there would be fewer satellites that are unable to hit a target at any given point in time. During the mission, we also can see pretty clearly that the rods being fired from the LOKI satellites are being propelled with some sort of rocket engine. As alluded to previously, even with the smaller mass of the rods, the increased velocity that they would be capable of still allows them to achieve even higher levels of kinetic energy during their descent. So while they are stated to be more precise than the ODIN rods due to their smaller size, they could also be considered to be even more powerful, depending on the exact trajectory towards their target. So being less massive, more present, and with higher destructive capabilities, the LOKI satellites represent a definitive upgrade from the ODIN design. In addition to the satellite weapon systems, we can also take a brief look at some of the support infrastructure also placed in space around the satellites. In the case of the ODIN Space Station, the attention to detail is actually pretty impressive. The ODIN Station is constructed with a modular design, the tried and true method seen in historical space stations. Many of its modules resemble similar ones on the International Space Station, such as the Quest Airlock and Destiny Laboratory. There are also 2 docking adapters with nearby robotic arms to facilitate cargo deliveries to the station. Most of the modules also appear to have grapple fixtures on them, which are used by station robotic arms to move modules around and reconfigure the station as needed. We can also notice that the diameter of the space shuttle docking adapter is smaller than this airlock that we're traveling through here. However, if the docking adapter is specially designed for the space shuttle, it makes a bit of sense since you might be able to manage pressurization a bit more cleanly than for an airlock opening out into space. Also, the shuttle is docking at an offset angle from the coordinate system of the rest of the space station, which isn't necessarily impossible, but it would be much more convenient for the docking adapter to be aligned to the rest of the station. Also notable is the text indicating that this is a United States Air Force space station, since this game was released before the formation of the US Space Force, and at the time the Air Force was responsible for space operations. Going inside the station, we see that the overhead and deck directions are labeled, since being in space, there's no actual up or down. Curiously though, the zenith direction, which is away from Earth, is labeled as the deck, and the nadir direction, or towards the Earth, is labeled as overhead. This is the opposite of how it is on the International Space Station, but I suspect that this was done in order to have the station aligned so that you could get some cinematic shots during this sequence. There's also a nice little detail here of these little bars on either side of the switches in the airlock. This is to prevent floating objects from randomly bumping into the switches and triggering them accidentally. We also have these sort of nets along the wall, which are used to store cargo that doesn't otherwise fit into a fixture along the walls. Since it's in zero gravity, it would just float away otherwise. We also see a couple of fire extinguishers on the station, which are good to have, but the fire extinguishers we use on Earth could be quite hazardous for an enclosed environment such as on a space station, so it would make a lot more sense to have some specialized firefighting equipment that's designed for zero gravity here. Also during this level, we encounter 8 total crew members on board the station, which is also the current maximum complement of the ISS. There's a bit of an inconsistency here in that the Federation astronauts come out of a different airlock than the one that the space shuttle docked to. If we look from the exterior of the station, we can see that the shuttle is docked to the nadir side of this sort of crosspiece module. Considering, though, that we eventually encounter more Federation astronauts coming from different parts of the station, it's easy enough to assume that they've just spacewalked over to different parts of the station as well. A little further inside the station, we see these tool drawers that very closely resemble those on board the ISS. And of course, we once again have the classic getting sucked out of an airlock scene. Now, while this isn't impossible, this does require a significant amount of air to actually be pushing you towards the airlock. So in most circumstances, this wouldn't actually happen in real life. However, considering there was just an explosion in this room, and without going into excessive calculations here, I think we can give this one the benefit of the doubt. Now, given that there are so many satellites orbiting the Earth right now, this kind of begs the question as to why we would need a station to support the ODIN satellite. The most obvious answer would be to have human crew members available for maintenance and upgrade tasks, and considering that this satellite is said to be a prototype, this does make some sense. You could also argue that having an armed space force available at the station would be useful for defensive purposes, but it doesn't seem like we have any weapons available during this sequence other than those brought by the Federation astronauts. There's also a few other points to be made regarding defenses of these weapon systems, but we'll talk about that later. A third argument could be that you want to have the crew responsible for firing this weapon be as secure and isolated as possible to prevent a hostile takeover, which we can see how well that went. Now, while these arguments might be somewhat compelling, we have to also keep in mind that having a human crew complement for a space station is an extremely expensive endeavor, and adds a massive amount of complexity to the overall mission. Not only do you need to have habitation for the human crew, but you also need to have life support, which is extremely complex and would require regular maintenance. Not to mention the added logistical difficulty of launching and maintaining a space station in addition to the ODIN satellite. If the station were pre-existing before ODIN was launched, then this might make a bit more sense, but if the station is designed solely to support ODIN, it seems a bit like overkill, ironically enough. Switching over to LOKI, this station is much larger than ODIN and seems to be comprised of 2 lengths of habitation modules separated by a solar array between them, along with a truss system holding all of it together, in addition to a central part of the station where the Satellite Launch Control Command Center is located. There doesn't appear to be any passageway between the 2 sections of the station, so this is essentially 2 space stations stuck together, which is an interesting way to design a station. Only the side that the attack is focused on seems to be equipped with cargo modules and robotic arms for capturing cargo vehicles. So we could suppose that this perhaps is the military half of the station, while the other side could be for civilian purposes. Also, just while we're still outside the station here, it is still worth pointing out that you would not be able to hear the rods being fired in the background here, as there's no medium for the sound to be carried from the rods to the astronauts. And as we hear it here, it sounds more like what you would experience if you were still located within Earth's atmosphere. During this space battle, the shuttle docking and fueling arm explodes, which, since we are in the absence of an atmosphere, means that both an oxidizer and a fuel were being loaded onto the shuttle at the same time, in order for both of them to be present to cause an explosion. And in addition to just generally wanting to keep explosive materials away from each other unless you absolutely have to, considering that this is a military space station, you'd think they would have maybe protected these systems a bit more if there was concern over them getting shot. On that note, we also encounter some explosive canisters in space, which would present the same hazard of storing oxidizer and fuel right next to each other. Now, something very interesting and strange that I found in this level is this shell casing that is rotating and spinning in a very unusual fashion. Now, it is possible that this is just a video game glitch, but it seems a little too deliberate to be that. What I think this is supposed to be is a representation of the Janibikov effect, or the tennis racket theorem. It can also be observed with objects other than tennis rackets, such as a smartphone. If you hold your phone like shown here and flip it around up in the air, you'll notice that it also rotates along its lengthwise axis, rather than only rotating about the axis you're flipping it along. In microgravity, this effect is even more pronounced, as you can see from this demonstration aboard the International Space Station. Now, from my brief research, it does appear that you need an asymmetrical object with a different moment of inertia in all three axes in order for this effect to manifest. And also, since I'm still stuck on Earth at the moment, I can't actually really test if this would function for a shell casing in microgravity. But in case this is an intentional game design, this is a very nice bit of attention to detail here. It's something that 99% of the time would just look like a video game glitch, if you even happen to notice it in the first place. So good job on that. Another great bit of attention to detail is the inclusion of these external ammonia tanks outside the station. These boxes are almost identical to the ammonia tank assemblies that are part of the International Space Station's external active thermal control system, which is responsible for maintaining comfortable and survivable temperatures within the ISS. So then, overall, the LOKI Station, while a bit more speculative than ODIN, does seem to be quite well designed. It has a mostly authentic and believable design as far as space stations go, and clearly has had a lot of thought put into it. So from what we've covered so far, there hasn't really been any definite reason why this sort of system couldn't possibly work. And to that point, I haven't even mentioned anything about miracle exceptions to the laws of physics like I usually do for these sci-fi reviews. However, while it might be feasible from a technical perspective, there are a lot of logistical and legal reasons why this would be very difficult to actually pull off. Perhaps one of the more obvious detriments to this sort of system would be the cost. As part of the explosive potential calculations, we found that the tungsten rods would have a mass of approximately 8,300 kilograms. Now, as you might expect, launching any amount of mass into space is expensive. While recently the cost has been going down thanks to SpaceX's Falcon rockets, you're still looking at between $50 and $100 million to get one of those up into space. Now, each of those launches can only carry so much mass up with it. Even the Falcon Heavy would only be capable of carrying up about 7 of these tungsten rods in one go, which Falcon Heavy is quite a big rocket, so just about anything else is going to take more launches than that to actually arm one of the ODIN satellites. But if you were to have a system such as LOKI, where you have rocket engines attached to these tungsten rods, that's going to increase your costs even higher, because then you have to consider the cost of all the engines you're going to be equipping these things with, in addition to the fuel that you're going to be sending up there. Now take all of that and compare it with the ICBMs that the United States has in its arsenal. The LGM-30 Minuteman III has a unit cost of only $7 million, and this thing can be equipped with a nuclear weapon if so desired. Also, the UGM-133A Trident II missile has a cost of just over $30 million. So while a space-based weapon system could be useful for other reasons, the cost is much higher than a similarly capable ICBM that could be launched from Earth. Another potential downside to having one of these weapon systems in space is that it might actually be more susceptible to attacks than you would think. For one, anything orbiting around the Earth is traveling very, very fast, And so even an impact from orbital debris could cause serious damage to any sort of space system in orbit. So it wouldn't really be impossible for an opposing military force to ram a satellite into your space weapon to destroy it without having to launch their own mission. Alternatively, we have recently seen tests from the United States, Russia, China, and India that have demonstrated the possibility of actually shooting down a satellite with an Earth-launched missile. Now, granted, you could possibly just maneuver your space weapon out of the way of these incoming projectiles or vehicles, but in the case of anti-satellite weaponry, this might not even be sufficient. So some sort of defensive measure might be required to actually preserve the space weapon's operation while in space, which is adding even more complexity to this already very complex system. Interestingly enough, though, there has actually been one historical incident of a space station being equipped with a projectile weapon, that being the Soviet OPS-2 station, publicly known as Salyut-3. And while that implementation of a weapon in space wasn't very practical, it did demonstrate that it is technically possible. A final reason why a military might not deploy one of these space weapons might be that it is most likely just plain illegal. Now, I know there's a bit of irony in that, but just hear me out. And before I go any further, just know I am not a lawyer. I took one space law class, and this is not legal advice. The Outer Space Treaty of 1967 is the primary international law regarding activities in outer space. This treaty is effectively universally accepted among spacefaring nations, and while it's quite old, it is still the #1 document to go to for space law. Article 4 of the treaty specifically mentions that nuclear weapons may not be placed in space, nor may other weapons of mass destruction. Now, the key here is the lawyer interpretation of what the words place in orbit around Earth and station such weapons in outer space actually mean. But if a country were to actually attempt to place one of these ODIN satellites into space, they would probably quickly run into trouble with this treaty. Also, because this is a treaty, it is a binding agreement between all of the nations that are part of it. So a breach of the treaty could be cause for escalation, and that's getting into geopolitics, so we won't go any further there. Bottom line, though, just by having one of these weapons existing could be a breach of international law, which would get its launching nation in serious trouble. Now, even after addressing these counterpoints, we still haven't really come up with a definite reason why this couldn't actually happen. Sure, it might be expensive and not the most well-defended of system, and while it might be illegal, international law is much more easily broken than the laws of physics. And so for this part of the video, I'm going to get kind of philosophical. For almost 60 years or so since the Cold War, the military capability to effectively annihilate the entire planet has been an ever-present concern. In addition to that, over the last 10 years or so, there has been research by the United States military to develop a system to strike anywhere in the world within an hour. And other countries as well have been developing hypersonic weapon systems that are much more difficult to intercept using traditional anti-ballistic missile systems. So the idea of a space weapon system that can strike anywhere on Earth within a matter of minutes isn't really new or original, from either the perspective of destructive capability or time till impact. The world has been spinning under a nuclear sword of Damocles for several decades now, and we're still here. And maybe unless you're in the military, there's not a whole lot you can do about that. So I personally prefer to take the stoic angle on this, which is to not worry about things that you don't have any control over. There's countless ways to die at any given moment, but that's no way to live life thinking about death every moment of every day. Maybe occasionally to give you some perspective, but not worrying unnecessarily over things you can't control. And especially on this topic, I would refer to a quote from C.S. Lewis in his paper On Living in an Atomic Age. If we are all going to be destroyed by an atomic bomb, let that bomb, when it comes, find us doing sensible and human things, not huddled together like frightened sheep and thinking about bombs. So basically, to summarize, obviously a world where nuclear annihilation is a constant possibility is not an ideal one, but is worrying really going to help anything? And on that hopefully somewhat cheerful final note, I'll say thank you very much for watching. If you enjoyed this review of sci-fi engineering, I've done several more videos on other sci-fi games that you might be interested in. I'd also like to shout out another channel, The Frosty One. If you're interested in seeing the realism of other games in this franchise, he does reviews on the historical accuracy of other Call of Duty games, and it's a really great time, so you should definitely check him out if that interests you. If only there were more Call of Duty games set in space. Anyways, if you'd like to be notified when I have another project ready to go, feel free to subscribe. And if you enjoyed this video, click the like button and leave a comment telling me so, or that I did a terrible job. Anywhere in between those is great. That's all I've got for now, so once again, thank you very much for watching.
Thompson, stick with the squad! Stay in formation!